Okay. Pair notes in front of you, solving inequalities with variables on both sides. This is chapter 3, section 5. Our essential question, what are the steps to solving with variables on both sides? Well, let's kind of review that. And I think you guys should be able to remember this from our equations when we looked at it from solving on both sides. Okay? So, first thing we always did was use the distributive property if we needed to. Okay, and be careful of that negative sign. If you're distributing a negative out, make sure that you're watching that negative sign, giving it out. You already have these in your notes on equations, so that's why we're not having you on these write them down again. Okay. Next thing that you want to take a look at is collecting like terms. Now, you can be looking in various places. You might be collecting like terms on the same side. Okay, that would be a multi-step, wouldn't it? And then you're going to look at both sides. So what you're going to do, and you have an option here, you can either always collect them to the left, but then you're going to have to worry about that negative business and flipping over the sign and everything, or just go to the side where there are more positive variables. And we talked about that before. It's a lot easier if you go where there's more positive variables, and you don't have to worry about, did you do this? Did you do that? Did you flip this over? Oh no, there's negative. Just go where there's more positive ones. And the last thing you want to do always is isolate the variable to solve. Again, at that point, once you've done those first two things, all that's left is a two-step process. You're going to get rid of the constant by adding and subtracting, and then you'll get rid of the coefficient by multiplying or dividing. So we're going to look at a couple examples here together and see if we can practice this variables on both sides. And remember, the one thing that we really need to deal with is that if we multiply or divide by a negative number, we have to flip the sign over. So that's the one thing that we want to be on the lookout for. Okay? All right. So here we go. Example number 1. We're going to solve and check this. So we have y, move over a little bit. Y is less than or equal to 4y plus 18. So I'm going to draw a line down. Sometimes I do, sometimes I don't, just to kind of work with people. There's a single y on the left, 4y on the right. There are more y's on the right where the 4 is, so I'm going to work on that. So what I'm going to do is I'm going to subtract a y from both sides. Now, some people get all edgy because that brings the sign down, but y minus y, that freaks them out and they leave it blank and it gets crazy. But if I have y and I take away y, doesn't that leave 0? So we want to put a 0 there. And then I have 4y minus y, which is 3y, and then I'm going to bring the 18 down. And now I'm going to just treat it like I would any normal two-step process. I would subtract 18 from both sides. And subtracting 18 does not change the sign over. So that's going to be negative 18. And for my last step, to get the y alone, I'm going to divide both sides by 3. Now dividing by 3 does not change the sign either. So negative 18 divided by 3 is negative 6. Started negative, stayed negative. Okay, so far so good. So we're going to check our solution by putting it in place of the y, and we're going to use an equal sign when we're checking. So 4 times negative 6 plus 18. And we're going to work this out. So negative 6 equals 4 times negative 6 is negative 24. Negative 24 plus 18 is 6 apart, and there are more negatives, so it's negative 6. So we're good to go. So this is our answer. Now again, if you don't like having the y on the right side, you want the y on the other side. Remember, if you put the y on the left and you want to switch it with the negative 6, you've got to flip the sign over too. All right, so any of these two would work. Let's try a second example. Here again, we have solving, and 4m minus 3 is less than 2m plus 6. I'm going to separate my sides. I have 4 m's on the left, 2 m's on the right. More on the left, so that's where I'm going to go. I'm going to get rid of the ones on the right, so I'm going to subtract 2m from both sides. And 4m minus 2m is 2m, and bring down that minus 3 is less than This now goes away, that's 6. And again, two-step process at this point. We're going to add 3 to both sides. That leaves us 2m is less than 6 plus 3 is 9. And then we're going to divide both sides by 2. And yes, we got a fraction. M is less than 9 over 2. And we're okay with fractions, because if we plug the fraction in and it works in our solution, then that's right. For those of you who struggle a little bit with fractions, we'll talk when I get back. 4 times 9 over 2 minus 3 equals 2 times 9 over 2 plus 6. Let me kind of see if I can move everything over a little bit. Give myself some more room. I felt like I was squeezing that in. Okay, let's look at this part here. Let's put 4 over 1. Now, if you know anything about fractions, you can cancel, right? 2 can go into 4 how many times? 2. And 2 times 9 is 18. So that just becomes 18 by itself. So 18 minus 3 equals. If we look on the other side and put 2 over 1 over here, the 2's go away. And all I'm left with is 9 over 1. And that's just 9 plus 6. Now it's not so bad, is it? So 18 minus 3 is 15. And 9 plus 6 is 15. So since both sides are equal, we know that m is less than 9 over 2. We're going to try one more on the front, and then we're going to write some things down on the back side. So let's take one a little bit more crazy. So I have 2 times k minus 3 in parentheses, and that's greater than 6 plus 3k minus 3. All right, so stick with the left for a second. On the left, I can distribute. So let me give it 2 to the k, and I would get 2k. And then 2 to the negative 3, that would give me negative 6. So just when I'm working on a single side, it doesn't matter what's going on. It leaves the sign alone. On the right side, I can put the 6 and the negative 3 together, can't I? So the 3k is going to stay, and 6 minus 3 is 3. So now again, I get to go back and evaluate. I have 2k's on the left, 3k's on the right. I'm going to keep the 3k's, get rid of the 2k's. So I'm going to subtract 2k from both sides. And that's going to leave a negative 6. Don't lose that negative there. And subtracting 2k's does not change the sign. 3k minus 2k is just good old k plus 3. Right? In last step, get rid of this constant. So subtract 3. Negative 6 and a negative 3 is a negative 9. And we have negative 9 is greater than k, or for those of you who like to turn it around, k is less than negative 9. So let's see if that's right. So here we go. 2 times negative 9 minus 3 is equal to 6 plus 3 times negative 9 minus 3. So let's work on the left side. Parentheses first. Negative 9 minus 3 is negative 12. 2 times negative 12 is negative 24. Let's see what happens on the right. I'm going to leave the 6 alone for a second. 3 times negative 9, negative 27. Going left to right, 6 minus 27 is negative 21. And negative 21 minus 3 is negative 24, so it works out. So this is our answer, here or this one. Doesn't matter which one you like. Okay. Now, I want to talk about something. Our special solutions. You guys remember special solutions? We saw those in equations. We had 2 special answers. One was all real numbers, and the other was no solution. Okay? Now, let's see about what does this look like in inequalities. Okay? Well, in inequalities, an example of all real numbers, 2 is greater than 0. Do we know that to be true? That's true, isn't it? So how do we get something like this when we have an inequality? Well, let's take a look at this. Let's try this problem. 2x plus 2 is greater than 2x. Right? Now, if we were to collect our variables on both sides, right? Our variables would go away, wouldn't they? And then we would be left with 2, and 2x minus 2x is 0. And we know that this is true. Anytime when the variables go away and the inequality is true, our answer at that point is going to be all real numbers. Okay? Let's take a look at one that would be no solution. Remember, for no solution, you can write this, right? The 0 with the line through it. Can't write 0 because 0 is a number, as we can just see. So let's take a look at this. How about 2x plus 5 is greater than 2x plus 8? Well, we got 2x's on both sides. So if we subtract 2x from both sides, that's going to leave us 5 is greater than 8. And that's false. We know that's not true. It's so not true. And because it's not true, that's going to tell us that our numbers are going to be, oops, wrong one. Sorry about that. Get the right pen here. No solution. So when it's false, it's no solution. It's true, it's all real numbers. Now remember, just like we did before, you have to show proof. Okay? I have to see the proof and the statement. The proof and the statement. Okay? Whether you say true or false, that part doesn't matter, but I need to see the proof that you're telling me it's one of these situations. And again, you can go back and look at that in the book, also in equations for the same thing. That's the end of this recording.